So in this video, we're going to look at a special kind of category of our network graphs or our network diagrams. These are called traversable graphs. Now, we're going to actually cover these a lot more later in the series as well, but the current definition I'm just going to give you guys to work with is that these graphs have the property that you can trace out a trail on the graph without repeating an edge or taking your pen off the paper, okay? So you should be able to draw this kind of all in one go. And remember, this is a trail, okay? And we are not repeating an edge or taking our pen off the paper. Now, you can see that this one here, this first one, is a traversable graph because it has a trail that includes every edge. Now, we are not repeating an edge and we are including every edge. You can see here, if we take this trail that they've given us, A, B, C, A, C, I will show you that we can actually trace this out without taking our pen off our paper. So we go A, B, C, and remember we can go in this, apologies, let's try that again. We're going A, B, C, I'm following the arrows, A and C. So I start and finish at a different vertex because it's a trail, and I can draw it without taking my pen off the paper, and I'm using every edge. Now, with this non-traversable graph, you can even pause the video and draw up this diagram that I have here, and you'll see that it is impossible to find a trail in a non-traversable graph that includes every edge. So you'll see as I try to do this, eventually I'll have to either repeat an edge or I'll have to take my pen off the paper. Let's just try one kind of option here. Let's say I go from A to D to B to C to D. Now, either way I go, I will have to kind of repeat one of these. So that's not going to work. Let's just try a different route. Let's just say we went A to C to B to D to A to B. I'm almost there, but I can't go anywhere here, right? Or I'd have to take my pen off in order to complete this. So any way you do it, you will notice that it's impossible to basically do this, make a graph that includes every edge. So this is how we can distinguish between the two. Now in example one, we want to first of all identify whether the graph is traversable. And if it is, we want to identify a circuit that includes every edge. So let's go through the first one. This one we can kind of pretty clearly see. Let's say we start at this vertex. Let's call this S for start. We can basically make our way through and not take our pen off the paper, and we are done. Now, what we've done is we've essentially identified a circuit here because we started at this vertex and we ended back up at the same vertex. So this is the start and the finish. So this graph, yes, it is traversable. And I just drew a circuit that would include every edge. Now with this one, we basically want to draw up a circuit. So, well, let's see if it's traversable. So can we draw something on here that uses every edge and we draw it without taking our pen off the paper? So let's have a go. So we'll start maybe here and we'll make our way around to here, 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 and here. Okay, so this was our start and our finish, and we were able to draw this up completely without taking our pen off our paper. Now, there's actually a property of these types of graphs that makes this possible. We will talk about that later in the series. But yes, this is a traversable graph, and we just drew an example of a circuit on here. So let's just do another one. Final one. Let's just try. So let's start at this one, and we'll go to here, to here, to here, 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 here. Oh, wait a minute. I can't go back. I can't go around, and I have to take my pen off my paper before I can get this part. So immediately we know that no, it is not traversable. Okay, so remember, we're just doing this exercise of trying to hit every edge without taking our pen off the paper. If this is impossible, it's not a traversable graph. If it is possible, then it will be traversable. All right, let's do this one. So it's saying for each graph, identify whether it is traversable, and if it is traversable, identify a trail, including every edge. So let's just check, and you can pause the video at any point if you like, draw these out, have a go on your own, but I'm just going through these questions. Now, for this particular one, I'm gonna start at this vertex. I'm gonna draw here, 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 and here. So it is traversable, yes, because I was able to start at one vertex and hit every single edge, but it's a trail, not a circuit like it was back here. The reason why, think back, is because we started at this one and we finished at this one. When we start and finish at a different vertex, this will be a trail. Okay, next one. Gonna give this a go. Now, you can begin at any edge as well, but we're gonna give this a go. We want to go through and see if we can draw this without taking our pen off the paper. Okay, once we get to here, we can't go anywhere without repeating an edge, and I've taken my pen off. That's the only way I can complete this. I might have just done it wrong. Let's just try a different way. Let's start from this vertex. So here to here to here, here, here. Okay, getting better, but still, oh, wait a minute. Okay, it was possible. So I did this all without taking my pen off. So yes, it included every edge, so that means it is traversable. Last one. Let's try this one in the end. Let's try to work our way around. And if it's traversable, then basically by drawing this, I would have identified a trail. So let's go through this one here. Here to here to here. Okay. And I've used every edge. And it's a trail because I started here and I finished here. So yes, this will also be a traversable graph. So this is how we can work through these network diagrams and draw up our these trails and test if they are traversable or not. But all of these ones will be, because we're able to draw it without taking our pen off the paper. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.